Hello everyone. Today we're going to continue our lesson which is on case 3 when both of the population variances and population standard deviation are unknown, small sample size, but you know that it has a equal variances. So, since the population standard deviation and population variances are unknown, and small sample size, therefore the test statistic used is t statistic, okay, or we also call it as t test, okay. T statistic or t test can be calculated as sample mean from group 1 minus sample mean from group 2 minus with the population mean group 1 minus with the population mean from group 2 divided by SP. SP stand for standard deviation pool, and here SP is multiplied with 1 over sample size from group 1 plus 1 over sample size from group 2. Okay, again, SP here, SP, SP here is standard deviation pool, whereby SP, whereby SP can be calculated as follows, okay? So, N1 minus 1, this one, sample variance from group 1 plus sample size group 2 minus 1, sample variance group 2 divided by N1 plus N2 minus 2. So this is the formula for standard deviation pool. So for the case 3, you need to calculate SP first. And then when you get the value SP, you then can multiply with this one. Square root of 1 over sample size 1 plus with a 1 over sample size from group 2. So similar to the previous case, denominator, this one, wait, okay. So this denominator, this is actually the standard error difference. So let's say that if the question asks you to calculate for the standard error difference, so this is the formula for case 3. Remember, the standard error formula is different and it is according to which cases. Okay, for this one, the standard error difference for case 3 is calculated as follow. Okay, and hence the critical value CV, critical value CV can be written as T, oh, so T with alpha or alpha divided by 2 with a degree of freedom N1 plus N2 minus 2. So this is actually your degree of freedom. This is the degree of freedom formula. Same goes for this one. This is actually the DF. Okay. Sample size group 1 plus with the sample size group 2 minus 2. Here, you need to remember that if you want to use alpha, make sure that you have a one tail test, okay? This is for one tail test. If alpha divided by 2, then it is for two tail test, whereby your H1 having the symbol unequal. For one tail, it is either greater than H1U, greater than or less than symbol. Okay. However, before you can proceed with case 3 or case 4, you must and have to conduct the Levene test for this one. Okay, actually you can refer to the slide slide 30. This is the case number 3. This is the case 3 which are we cover today. Case 4, I'm gonna cover it later. Okay, this is the case 3. Okay, again, before you can proceed with case 3 or case 4, case 3 and case 4 require you to conduct the Levene test. It means that before you want to calculate for the test statistic for case 3, test statistic for case number 4, you need to conduct the Levene test. So, do you still remember how to conduct the Levene test? Actually, the Levene test, it is similar that you have learned in chapter 3. For Levene test, we use Levene test in order to know whether the population variances equal or unequal. So that's why we conduct the Levene test. Let's say if the Levene test show equal variance, then we need to proceed with case number 3. But if Levene test show unequal variances, then we should proceed with the case number 4. Okay, you look here. This is equal and this is unequal. So that's why we need to conduct the Levene test, because we want to know whether the population variance is equal or not. If it is equal, then we need to use case number 3. If it is unequal, then we need to use the case number 4. Okay, so if you cannot remember how to conduct the Levene test, let me show it one more time for you. Okay, basically, to conduct the Levene test, okay, so let's say that this is the sample output. Okay, wait. This is the sample output. Before you want to proceed with case 3 or case 4, you need to conduct the Levene test. Can you see here? Levene test. Levene test for equality of variances. Okay, make sure you look at this column, Levene test. The next column, which is this one, is t-test for mean. Okay, this one is for mean. And this one is for variances, difference. Okay, if you want to conduct the Levene test, you need to look at this column. Okay, so again, we're going to start with the, okay, again, Levene test is used to test the, okay, to test the equality of variances. Variances, okay, variances. All right, so whereby we start with the hypothesis, whereby the hypothesis for Levene test can be stated as null versus alternative, whereby the null hypothesis is we assume, this one, assume equal. Remember I told you, for null hypothesis, the symbol is always equal symbol, or assume equal variances. Okay. So for now, for alternative hypothesis, population variance group 1 is unequal to the population variance group 2. So this one, assume unequal variances. Okay, so after hypothesis, what's next we can do is step number 2, you write the p-value. Remember, the p-value is, you do not need to calculate the p-value because p-value is given. It is given in the output. For example, look at this table. This is the p-value. SIG. SIG is not sigma, okay? SIG is significant. It is not sigma, okay? Again, this is not sigma. SIG stand for significance value, whereby this is your p-value. In other words, this is your p-value. So the p-value shown here is 0.79. So you just need to state 0.79. Done. Then we move to the third step, which is decision. Again, if you use p-value, we will compare p-value with alpha. So here, your alpha is, okay, look at here. If you want to know what is your alpha, just look at here. 95%. So it means that your alpha is 0.05. How I get 0.05? Okay, 100 minus 95 equal to 5. 5%, right? 5%. So 5 over 100. So equal to 0.05. So your alpha is actually 0.05. Decision here. So since p-value 0.79, of course, the p-value is literally larger than alpha, right? 0.79 is obviously greater than 0.05. So what happened if the p-value greater than alpha? We can reject the null hypothesis. Okay, full stop. And then you go to the last step, which is the conclusion. Okay, what happened if you reject the null hypothesis? Okay, now you reject the null hypothesis. This is null, right? This is null and this is alternative. You reject. It means that you take the H1. So the conclusion is assume unequal, you fail to reject. You fail to reject. Okay, you fail to reject null hypothesis. Okay, p-value greater than alpha, then you need to fail to reject the null hypothesis. If p-value less than alpha, we reject the null hypothesis. Okay, again, p-value greater than alpha, we fail to reject the null hypothesis. But if p-value less than alpha, then we can reject the null hypothesis. Therefore, here we assume equal variances. Since we fail to reject, right? Okay, we fail to reject. We cannot reject the null hypothesis. When we fail to reject the null hypothesis, then it means that we need to take the null hypothesis. Therefore, we assume equal variances. Okay, so I go back. So this is your output, right? Can you see here? Okay, can you see here? Equal variances assume, meaning that equal. This one, equal variances not assume, meaning that unequal. Okay, so according to our finding just now, we found that the variances are equal. So we can you can cancel out the below row. It means that we will take the value, this one. Okay. Alright, so that is for Levene Test.